Hello dear students, I welcome you all to the second part of the video on exercise 2.3 on functions. Okay, so far we have understood what is the meaning of function. Yes, so the definition of function says that every element of your first set, if f is a function from x to y, then every element of first set has to be mapped. Yes, and the next thing that we learned is one element cannot be mapped with many element. Okay, so one element gets mapped only with one element. All right, so you just need to remember that. Okay, so that's about your definition of function. So today we are going to learn the type of functions. Okay, so the first type is called one-one function, and one-one function is also called injective function. Okay, so the definition says this. Okay, so it's going to be difficult for you to understand. So let's try to understand what is the meaning of one-one function. So in one-one function, what happens is, if function is from x to y, then every element of this will have different image. All right, every element of this will have different image. So what is the meaning of this? Let's try to understand using the diagram out here. Okay, so if I go to this first arrow diagram, this is my set x, this is my set y. So function is from x to y. All right, so we see that a is mapped with q, b is mapped with s, c is mapped with p, d is mapped with r, isn't it? So let's see whether this is function or not. So first set, in the first set every element is mapped. Yes, so that's why this one condition of a function is satisfied. Now second condition says every element will get mapped only once. For example, a is mapped once, yes, b is mapped once, c is mapped once, d is also mapped once. Okay, so here what is happening, every element, that is a, b, c and d, are having different image, isn't it? The image of a is q, image of b is s, image of c is p, and image of d is r. So if every element of your first set will have different image, then such kind of functions are known as one-one function or injective function. Okay, so please don't get confused. Now let me take one more here. Let me take this case. So this is my x and this is my y. So the image of a is q here. Yes, so let's see whether this is a function or not first. So this has to be a function because every element here is getting mapped. Yes, all the elements are mapped, and on top of that what happens, every element is getting mapped only once, isn't it? A is mapped only once because only one arrow is going from A. B is also mapped only once because only one arrow is going from B, right? So from C also only one arrow goes, means C is also mapped once, D is also mapped once. So we have, this is also a function, but the thing is, here we see that B and D both are having same image, and what is that image? Image is R, isn't it? But for a function to be one-one, what should happen? The images should be different. All right, although this is a function, but the images of b and d are not different, they are same here. So that's why this is not one-one. Okay, so this is one-one function or injective function. All right, now in examples or in questions, if the question is asking you prove that or check whether the function is one-one or not, then you can go for two techniques. One is this one. Okay, so how we are going to make use of this, we'll understand using the problems only. So you need to note down these things. Okay, so one is this. If you want to prove that the function is injective, you can either use this or you can use this. All right, fine. So this is my one-one function. Now as I said, this is my one-one function. So this is my one-one function, and next is onto function. Okay, so onto function is also known as surjective function. Now what's the meaning of this? Let's try to understand here. Now in onto function, one thing that you need to keep in mind is you have to always go for the second set here. For example, if my function is from x to y, we always need to look for second set, that is y. Okay, so this is my x, y, x, y. So in onto function, in the second set, all the elements should be mapped. I repeat once again, in the second set, all the elements should be mapped, then only the function will be the onto function. Alright, so for example, if you go here, in this we have got only 3 in the second set, yes, and all the 3 are getting mapped, isn't it? See, P is also mapped, Q is also mapped, and R is also mapped. So this becomes my onto function. Alright, similarly here we see that in the second set P, Q, R, S, all the 4 are getting mapped. So that's why this is also onto. Okay, so this is my 1, 1 also, and this is my onto as well. Fine. Now let's check whether this is onto or not. This is not onto. Why? Because P is not mapped from the second set, isn't it? So this is, see, already we know that this is a function, but this is not onto function. Okay, fine. Okay, so we'll have a look at this question at last. So in onto function, what we need to do is all the elements from the second set is mapped with some element or all element of this. That is the first set. Alright. So the definition says for all y belonging to second set, there exists some x. Okay, there is some x in the first set such that the function maps x with that particular y. Okay, why am I taking for all y, for every y? Because every element has to be mapped. So that's why I am choosing all the elements from y. So from all y belonging to the second set, there is some element in the first set which is getting mapped with that particular y, that is f of x is equals to y. So this is how we are going to show whether the function is onto or not. Okay, now these are the two main things that we need to understand, because the same thing, that is 1, 1 and onto, is going to be useful in your class 12 as well. Okay, now if there is a function which is 1, 1 and onto at the same time, then such kind of function is known as bijective function. Okay, so if a function is both 1, 1 and onto, then such kind of function is known as bijective functions. So these are the very important ones for us. Alright, now next kind of function is many one function. Now I am just going to give you example out here because they are not going to be so useful for us. So many one function means function of this kind. For example, we already know that this is a function, isn't it? Okay, so here we see that two elements are getting mapped with 1. That means the images of two different elements is same. Alright, so not only 2, but we can have 3 as well. So if, for example, here, let me take this one. So here we see that these two are having same image. Yes. Okay, so this kind of function is called many to 1. Okay, so this is called many one function. Alright, so this function is onto and many one function. Okay, so this is also many one function. Let's check, because B and D both are having same image, and similarly A and C, they are also having same image here. So this is what kind of function? See, this was not 1, 1, we know that. Yes, we have checked earlier. This was not 1, 1, this was not onto, but this is what kind of function? This is many one function. Okay, now the next is into function. Okay, so one more thing that I want to say here is, as in onto function, as all the elements are getting mapped here, isn't it? From the second set, all the elements are getting mapped. Now what is happening? This full set, what do we call this? We call it codomain. Remember, the first set is called domain for the function. Alright, so for any function, the first set is called domain, second set is called codomain. Okay, and the elements from the second set to which the elements are mapped, if I put all those elements in a set, that particular set gives me range. For example, in this case, okay, let me take this. So in this is a function, we know that, yes, but in the second set only two elements are getting mapped, so that is Q and R. So if I put Q and R in a set, then this set will be the range of this here. Alright, and if I ask you what is the codomain, you have to note down all the elements, that is P, Q and R. So P, Q and R gives you codomain, and Q and R, because only these two are getting mapped, so this gives you the range. So in onto function, what you need to remember is, here since all the elements are getting mapped, yes, so in onto function codomain and range will be same. Okay, so codomain will be equals to range in case of onto function. Alright, so we have understood many one function. Now in into function, what happens is, it's just going to be opposite of onto function. Now in onto function, all the elements are mapped from the second set, isn't it? But in into function, all the elements will not get mapped. Alright, for example, here we see that all the elements are mapped, so that's why this is onto, this is also onto, yes, but here this is a function, we know that, yes, but P is not mapped, isn't it? One element is left out from the second set, so that's why this kind of function is known as into function, where not all the elements from second set is mapped. Alright, so in into function, what happens? This is my domain, this is my range, and this is my codomain, isn't it? So basically, is this the subset of this? Yes, right? So this is a proper subset, in fact, yes, because this is smaller than this, isn't it? So in fact, this is the proper subset of this. So in case of into function, what happens is, range will be a subset of codomain. Alright, so remember, if I put this sign, this means equal to also, it can be range, can be equal to codomain as well, but since this is a strict, okay, so this is called strict subset or proper subset, since range is a proper subset of codomain, so that's why in into function we write this. Alright, so don't get confused, sometimes you may see in objective as well, for onto function codomain and range will be equal, but whereas in into function range will be proper subset of codomain. Alright, so pause the video and note down the important concepts. Okay, let's take the first question for the day, that is question number 16. So question says, let A equals to this set, B is equals to this set, and the function is given by this one. Okay, so this is a function from A to B. Show that f is 1, 1 but not onto. So in order to understand this, let's draw arrow diagram, because arrow diagram makes our work very simple. So we have got A, so within A we have 1, 2 and 3, and within B we have got how many elements? 4 elements. So this is my B. So we have got the elements 4, 5, 6 and 7. Okay, so let's see how is the mapping happening. So we have 1 is mapped with 4. Yes, so 1 is mapped with 4, 2 is mapped with 5. So 2 is mapped with 5 and 3 is mapped with 6. So question says, prove that the function is 1, 1 but not onto. Now it is 1, 1 because every element in A has different image in B, isn't it? Yes. So clearly every Yes, so since every element in A has different images in B, so that's why the function is 1, 1 as per definition. Now we need to show that the function is not onto. Now for a function to be onto, what should be there? We must have range and codomain to be equal. But here we have range. Okay, so range is what? What is the range? The elements to which the elements from the second set to which the function is mapped. So what are the elements to which it is mapped? It is 4, 5 and 6, isn't it? So this is my 4, 5 and 6. Yes. And what is codomain? Codomain is the whole set B. Yes. And what is set B? It is 4, 5, 6, 7. Yes. Now clearly we see that range and codomain, they are not equal, isn't it? So since range is not equals to codomain, hence f is not onto. Alright, so pause the video and note it down. Now let's take this question. So question 18 says, show that the function f from q to q. So what do you mean by q? Q is the set of all rational numbers. Alright, so functions from q to q defined by fx equals to 3x minus 2 is 1, 1. Okay, so we need to show that this function is 1, 1, and to show that a function is 1, 1, there are two techniques available. So we can make use of this. Alright, so let me make use of the first one, because in most often we make use of the first one. Alright, because my job is going to be easy if I use the first one. Okay, so let's see how to do that. Okay, so we have if, so what is the meaning of this? If this, then this. That means this is given to us. Yes, we need to prove this. Alright, fine. So given is, or let me take, let f of x1 is equals to f of x2. Okay, now what is f of x? Fx is 3x minus 2. So that's why f of x1 will be, instead of x I have written x1 here, right? So that's why here also instead of x I will write x1. So we have 3x1 minus 2 instead of this. So equal to, we have f of x2. So instead of x we have got x2. So here also instead of x I am writing x2. So we have 3x2 minus 2. Alright. So 2 and 2 gets cancelled. So we have 3x1 equals to 3x2. And from here we see that 3 and 3 gets cancelled. So we have x1 equals to x2. Now see, we started with this and we showed that x1 is equals to x2. So that's what I wanted to show, isn't it? Yes. So therefore function, okay, so function is, therefore the function f is 1, 1. Alright, so that's what we need to show. It's very simple. So pause the video and note it down. Next, we need to show that the function f from n to n stands for set of natural numbers defined by fm equals to m square plus 2m plus 3 is 1, 1 but not onto. So let's see how to do this kind of sum. Okay, so first part is simple. We need to show 1, 1. So let's see how to do 1, 1. Okay, so for showing 1, 1, what do? We take this, isn't it? So we have, let f of x1 equals to f of x2. Alright, so here instead of m we have got x1, isn't it? So that's why here also instead of m I have to write x1. Okay, so we have f of x1 becomes x1 square plus 2x1 plus 3, isn't it? We have similarly f of x2 becomes x2 square plus 2x2 plus 3. So let's see what are the things that are getting cancelled. So we have 3 and 3 gets cancelled, isn't it? So is there anything that those are getting cancelled? No, we don't have anything, isn't it? So let's take everything here, okay, to the left hand side. So we have x1 square, so this comes over here becomes x2 square, isn't it? So we have plus 2x1 minus 2x2 equals to 0. So we can factorize this, isn't it? So this becomes your x1 plus x2 into x1 minus x2, isn't it? And from here we see that 2 is common. So if I take out 2 commons, then we have x1 minus x2 equals to 0. Now again here with this and this we see that there is a common, that is x1 minus x2. So let me take out x1 minus x2 outside. So here we are left with x1 plus x2, and here we have plus 2 equals to 0. Now here we see that product of two numbers is 0. So either this is 0 or this is 0. Now can this be equals to 0? Let's see. Now what are x and y? See here. This is the element. See here carefully. This is the element coming from the first set. Alright, so that means m is a natural number here, and this result is there. This also comes from the second set. Remember one thing, this part comes from the first set, and how much ever you get here, this comes from the second set. Okay, so x1 must be coming from the first set, isn't it? Yes, so x1 is a natural number. Similarly, this x2 is also coming from the first set, isn't it? So that's why this x2 is also natural number. So x1 is a natural number, x2 is a natural number. So natural number plus 2 is always positive, isn't it? Choose any values for x1 and x2. They have to be natural numbers. So altogether this will be positive. So this cannot be 0 because this is positive, isn't it? So from here we see that x1 minus x2 will be equals to 0 because this is not 0. Yes, so since you have to write x1 plus x2 plus 2 is not equals to 0. So if this is not equals to 0, then obviously this has to be equals to 0, and from here what do we get? We see that x1 and x2, they are equal. Now we started with this, isn't it? And where we landed? We landed at x1 equals to x2. We have showed this. So if I am able to show this, this means that the function is 1 1, isn't it? So therefore f is 1 1. Alright, so this is how we show the function to be 1 1. Now we need to show that the function is not onto. Okay, so I don't have space here, so pause the video and note it down. Okay, so now we want to show that the function is not onto. That means you are disproving something out here, isn't it? And we know that whenever we disprove something, we always look for some counter example. Okay, so we have to look for counter example here. But how to arrive at counter example? Let's see. Alright, so let's see first the general rule in order to prove that a function is onto. Okay, so we'll just arrive at some point, and at that point we'll give some counter example. Okay, so in order to prove that a function is onto, what we need to show is we need to first choose a random element y from the second set, because that has to be mapped with, because we know that in second set every element is mapped from some element from the first set, isn't it? So I'm choosing one random element from the second set, and that has to get mapped. Okay, so I'm showing ontoness here, or I'm checking ontoness. So let y be chosen from the second set. And what is the second set here? Second set is again n, isn't it? So let y from second set be arbitrarily chosen such that, okay, so I have to choose in such a way that f of x will be equals to y. Now what's the meaning of this? It means that this y is mapped with element x from the first set. Alright, now we need to find what is this x. Okay, now after finding this, if x also belongs to n, remember, if this x belongs to the first set, then my function becomes onto. Alright, let me repeat once again. Choose any random element from the second set, because in second set every element will be mapped. Okay, and let me take that particular element from the first set to which y is mapped to be x. Okay, so such that fx equals to y. That's what I have written here, and I need to find what is that x. And if that x comes from this set, then function is onto. But if this x do not belong to this, then what is the meaning of this? Function is not onto. Alright, so I have written that's what here. So let's see what is fx. Now fm is this much, so that's why fx becomes x square plus 2x plus 3, isn't it? Yes, so this is equals to y here. Now as I said earlier, we need to find what is the value of x. Okay, so let's see what will be the value of x here. So this is a quadratic equation, remember. Alright, so we have x squared plus 2x plus, let me get this thing out here, so this becomes 3 minus y equals to 0. Now treating this as a constant, this becomes your quadratic equation. So let's apply quadratic equation formula. So quadratic equation formula says x will be equals to minus b is 2 plus minus square root of b square means 2 square minus 4a. A is how much? 1, and c is 3 minus y whole divided by 2a, isn't it? And what is a? A is 1 here. So let's quickly simplify this. So we have minus 2 plus minus, so we see that this is 4, so 4 can be taken outside as common. So if I take 4 common, then due to square root sign, the square root of 4 becomes 2. So within square root sign we have 1 minus, okay, so from here we have got 3 minus into minus is plus y by 2. Yes, so you see that 2 is common here, so 2 and 2 gets cancelled, so this becomes minus 1 plus minus square root of, so within square root we are going to have y minus 2, isn't it? So pause the video and note it down, I don't have space here. Okay, so we got x equals to this one, isn't it? And remember, we have chosen y from natural number, okay? And if y is coming from natural number, then the value of y can be 1, isn't it? Because 1 is also a natural number. Now when y is equals to 1, see, till here we have done the normal thing, okay? So now this is your counter example. During counter example, what do? We choose some specific example. Here I have chosen that specific example to be y equals to 1. Okay, so when y is equals to 1, then let's see what do we get. So then x is equals to minus 1 plus minus square root of y is 1 minus 2, isn't it? So this is minus 1 plus minus square root of minus 1, isn't it? Now do we have square root of negative number? No, right? So that's why this is not a natural number. In fact, this is called imaginary number. Yes, so from here we see that x do not belong to the first set, that is natural number. Yes, so I said in the beginning that y is chosen from second set such that fx is equals to y, isn't it? So if I choose y equals to 1, then there is no element from this which is mapped with 1 in the second set. Alright, I hope the thing is clear to you. If I choose y equals to 1, okay, so this is my first set n, this is my second set n, and we know that within n we have got 1, 2, 3, and it continues similarly 1, 2, 3, it continues. So every element is mapped, so I am choosing 1. So whenever I choose 1, then I see that there is no element from the first set which is mapped with 1. Yes, so that's why the function is, therefore f is not onto, because we see that 1 is not mapped with any element from the first set, isn't it? So that's why f is not onto. So this is how we show whether a function is onto or not. So pause the video and note it down. Okay, so next we have question number 21. So there are two questions given to us. I'll take question number 2 for you. So question says, in each of the following cases, state whether the function is bijective or not. Justify your answer. So the function is from R to R, set of real numbers to real numbers, defined by fx equals to 3 minus 4x. So we need to check whether the function is bijective or not. So that means we need to check 1, 1 and onto. Alright, so let's check 1, 1 here. So for checking 1, 1, let me take f of x1 equals to f of x2. Okay, so what is f of x1? F of x1 becomes 3 minus 4x1. So 3 minus 4x1 is there. So this becomes 3 minus 4x2. So 3 and 3 gets cancelled. So we have minus 4x1 equals to minus 4x2. So minus and minus gets cancelled. 4 and 4 can also be cancelled. So we have x1 equals to x2. So this means that f is 1, 1. So 1, 1 case is very simple. Now let's try to prove ontoness here. Okay, so to prove onto, we need to prove, or we need to choose random element from the second set, that is y, isn't it? So for proving ontoness, so let okay, now we need to show that this y comes from the this x comes from the first set. So if this x comes from the first set, then it means that the function is onto. If this x do not come from the first set, then the function is not onto. Alright, so what is fx? Fx is 3 minus 4x equals to y. So from here let's calculate what is my x. So we have 4x equals to 3 minus y, and from here x turns out to be 3 minus y whole divided by 4, isn't it? Now put any value for y, because y is what? Y is real number. Real number means it's any number from the real line. It might be decimal as well, it can be square number as well, square root number as well, isn't it? So it can be whole numbers, integers, it can be anything. So put y to be anything, you will find that x will also be a real number, that is x is also coming from the first set. Okay, so for any y belonging to R, it is clear that x also becomes my real number. Yes, so that means x is coming from the first set. So therefore we say that f is onto. Now as we know that f is 1 1 and we know that f is onto, so therefore f is bijective. Okay, so we know that a function will be bijective if it is 1 1 and onto. So this is how we do this kind of sum. So pause the video and note it down. Alright, so we have next question, question number 22, which says show that the function f from, see the first set is r minus 3, so it's a real number, real line, and from that real line you are removing 3. Alright, so this is the meaning of this. For example, if this is my set, these two are my set, and this is my r minus set with 3, and this is my r, so function is from this to this. Okay, so in this we have only, or we have all the real numbers except 3, so that means 3 is not present in this set. This is the meaning of this. Okay, r minus 3 means 3 is not present in this set, but in this all the real numbers are there. Alright, so this is the meaning of this. So we need to prove that the function f, which is defined as fx equals to x minus 2 whole divided by x minus 3, is 1 1 but not onto. Let's see how to do this. So let's prove 1 1. So 1 1 is easy, we know that. Let fx1 equals to fx2, so that's what we do. So we have f of x1 can be written as x1 minus 2 divided by x1 minus 3, isn't it? So f of x2 becomes x2 minus 2, x2 minus 3. Alright, so let's do the cross multiplication. So we have x1 minus 2 into x2 minus 3 equals to, we have x1 minus 3 into x2 minus 2, isn't it? So let's quickly multiply. So we have x1 x2 minus 3 x1 minus 2 x2 plus 6, and similarly here we have x1 x2 minus 3 x2 minus 2 x1 plus 6, isn't it? So plus 6 and plus 6 gets cancelled, this and this also gets cancelled. So from here we see that we have minus 3x1. Let me get x1 out here. So we have plus 2x1 equals to, we have minus 3x2 here. Let me take this x2 over there, becomes plus 2x2, isn't it? So from here this is minus x1 and this is minus x2. So minus and minus gets cancelled. So we have x1 equals to x2. So what's the meaning of this? This means that f is 1 1, isn't it? So therefore f is 1 1. Okay, so this is my first part. Now second part is we need to prove that this is not onto. Okay, so let me choose one random element. Let y be chosen randomly from the second set. What is second set? Second set is R. So let y belongs to R be arbitrarily chosen such that fx equals to y. Yes, and what is fx? Fx is x minus 2 whole divided by x minus 3, and what is our aim from here? Our aim is to find what is the value of x, and we will check whether that x comes from this set, that is the first set, or not, isn't it? So let's calculate what is the value of x here. So we have here, we have got in the denominator 1, so let's do cross multiplication. So we have x minus 2 equals to, this becomes xy minus 3y. So get this x out here because we want to find the value of x. So we have x, let me take this 2 over there. So we have x minus xy equals to 2 minus 3y, isn't it? So from here x is common, so 1 minus y is there, 2 minus 3y. So from here x will be 2 minus 3y whole divided by 1 minus y, isn't it? Now we need to prove that, or we need to disprove here, right? Because we need to show that this is not onto, so that means we need to disprove here. So in order to disprove ontoness, we have to choose counter example, or we have to form counter example, isn't it? So let's take, see, y is coming from R. That means the value of y can be anything, isn't it? So that's why the value of y can also be 1, isn't it? So if I choose y equals to 1, then what happens to the denominator? This becomes 1 minus 1, which is 0. That means denominator becomes 0, and when we know that if we divide anything by 0, that gives me undefined number. That means x becomes undefined, isn't it? Yes. So when, or as y belongs to R, when y is equals to 1, then clearly x is undefined, isn't it? So if there is no value of x which is mapped with y equals to 1, then this means that the function is not onto. There is no x in the first set which is mapped with the number 1 in the second set. Okay, so therefore we directly conclude that f is not onto. Alright, so here my counter example was y equals to 1. So pause the video and note it down. Now in this question we need to show that the function from R to R defined by this is neither on 1 nor on 2. That means in both the cases, that is in 1 1 and another on 2, in both cases I need to give counter example. Okay, so let's see 1 1 here. That is, I am going to give counter example for 1 1. Okay, so whenever you see square, then what we can do here is we can take, or let's find what is f of 1 and let's find what is f of minus 1. Okay, so we have, if you see here, we have f1 will be 3 into 1 square minus 2, isn't it? Instead of x I have written 1. So how much is this? 3 into 1 square is 1, yes, minus 2. So how much is this? 3 into 1 is 3, minus 2 is 1. Alright, so we have similarly 3 into minus 1 square minus 2, isn't it? So minus 1 square is how much? This is 1, so 3 into 1 minus 2, and again this is also 1. Okay, so clearly f1 and f of minus 1 both are same, isn't it? So f of x1 is equals to f of x2 here, but x1 and x2, they are not equal, isn't it? x1 is 1, x2 is this one, so they are not equal. Although they are equal, but we have x1 and x2, they are not equal. So this is against our definition of 1 1, isn't it? So that's why f is not 1 1. Alright, so the first part is done. Second part is ontoness. Okay, so let y be chosen from the second set. Okay, so let y be arbitrarily chosen such that fx equals to y. Alright, that is, what is fx here? Fx is 3x square minus 2 equals to y. So the value of y is this one, and this y is coming from the second set. Right, now we know that this x is coming from, see, fx means this x is coming from the first set, isn't it? Now we know x belongs to R. So if x is coming from real number, then we know that x square is always positive or equals to 0. See, if you choose any value for x from real line, we see that the number or the square of it will be always positive, or if I choose x equals to 0, because 0 is also a real number, then x square will also be equals to 0. So that's why I am writing x square is greater than or equals to 0. Right. So we don't have x square here, we have 3x square. So let's multiply with 3. So we have 3x square will be equals to greater than or equal to 0. Yes, but here we have minus 2 as well. So we have 3x square minus 2 is greater than or equals to minus 2, isn't it? So I am subtracting 2 on both the sides. And what is this actually? This is my y, isn't it? So y is coming from this. Now, or y is greater than or equals to minus 2, isn't it? Now we know that what is this actually? This means, okay, so if I draw a real line, this is my minus 2. So the value of y can be equals to minus 2. So let me include this minus 2, and the value of y has to be greater than minus 2. So greater than means we have to go this way, isn't it? So what is this? This is what kind of interval? This is closed minus 2 comma infinity, isn't it? So wherever infinity is there, we'll put open bracket. That means therefore y belongs to what? Minus 2 comma infinity. And what is this? Y is what? Y is the second element, isn't it? Second element from the second set, isn't it? So here we see that y is coming from this only. Yes, that means if y is coming second element are coming from this set, then my range is what? Range is this, because set of all second elements give me the range. Okay, so therefore range is minus 2 comma infinity. Please learn this here itself, because in the next exercise as well we are going to do the same kind of work, that is to find the range and domain. Will work in the second exercise or the next exercise. Okay, so this is my range, and we know that in onto we have codomain and range will be equal. And what is codomain? Codomain is second set, which is R. Yes, so codomain is equals to second set, that is R. Now are they same? No, right? So this is, see, real line is extending this way as well, but this interval is only this much. So that's why here range and codomain, they are not equal. So that's why f is not onto. So that's what you need to write at last. Okay, since range is not equals to codomain, hence f is not onto. So pause the video and note it down. So this is the last question from your exercise 2.3, which says if A is a set R minus of minus 2. So hope you remember the case which we did earlier. So this is my set A equals to R minus of minus 2. That means this is a set of all real numbers except minus 2. So you have to remove minus 2 from here. Okay, and we have got similarly another set B, which is R minus 1. So this is also set of real numbers, but 1 is removed from this particular set, isn't it? So functions from A to B, A to B. All right. Now what we need to do here is we need to show that this function from A to B is 1-1 correspondence. Now 1-1 correspondence means the function is bijective. Okay, so this is one more name for the function to be bijective. Okay, so let's take 1-1 here. So 1-1. Okay, so 1-1 we have already seen for this kind of case. So you will try 1-1 by yourself. Let me do onto here. Okay, so let y be randomly chosen from the second set. And what is second set? Second set is b. All right, so let y belongs to b be arbitrarily chosen such that fx equals to y. Now what is fx? Fx is x minus 3 by x plus 2 equals to y, and our aim is to find what is x, isn't it? So let's find what is x. So we have this is x minus 3 equals to xy plus 2y. So from here we have x. Okay, so let me directly write what is the value of x. So from here you will find that x will be this much. Alright, so you will verify by yourself. Now let's check whether this x comes from the first set, that is a, or not. Okay, now see, this y is coming from b, isn't it? See, y is coming from b, and if y is coming from this set, then can y be equals to 1? No, because here 1 is removed, isn't it? So as, okay, so let me erase this part. Okay, so as y belongs to b, clearly y will not be equals to 1. Okay, fine. Hence, if you choose any value for y, other than 1, you see that x will be a real number. Okay, hence x belongs to real number. All right, choose any value for y other than 1, you will find that this x belongs to R. But we need to show that this x belongs to first set, that is R minus of minus 2, isn't it? That means the value of x cannot be minus 2. That's what we need to show. Okay, so let's see what happens if x is equals to minus 2. Okay, now if x is equals to minus 2, then let's see what happens from this. Okay, so let me call this as 1, equation 1. Then from 1 we have, instead of x I am writing minus 2. So minus 2 equals to 3 plus 2y whole divided by 1 minus y. So let's do the cross multiplication here. So this becomes minus 2 plus 2y equals to 3 plus 2y. So 2y and 2y gets cancelled. So we have minus 2 equals to 3. Is this possible? No, right? Which is not possible. That means x is a real number, we understood that. But on top of that, x cannot be equals to minus 2 as well. Because if x is minus 2, then we are getting this, which is not possible. Yes? So clearly x cannot be equals to minus 2. Yes, hence x belongs to real number, but from that real number I need to remove minus 2 because the value of x cannot be minus 2. So I have removed minus 2. That is, x is coming from, what is this? This is the first set, isn't it? That is a. So for any value of y belonging to the second set, there exists some x from the first set such that fx equals to y, isn't it? So therefore f is onto. So the first case I have not done, that is 1 1. So you will find that f is 1 1 as well. So you proved that f is onto as well. So at last you will write, hence function f is a 1 1 correspondence, or you will write the function is bijective. So with this we close for the day. See the solved examples and try the sums from there as well. So pause the video and note it down. Thank you very much.